Hello everyone, welcome back to my YouTube channel. So today we are going to discuss about important system design terms that everyone must know. So if you guys are preparing for your system designs, LLDs and HLDs, right? So you should know these terms, okay? So if I ask you to design a system design for parking lot system or any other booking system, right, or this Hotstar application, Netflix application, okay, so in all these system designs, okay, you will see these terms like cache, rate limiting, okay, all these terms, data indexing, data sharding, okay, so these terms will come inside all these system designs, okay. So we are going to discuss about these terms, okay, specifically today, and later on when we are going to discuss about the system design of these topics, then we will directly use these terms, okay. But before creating system design of these things, let's first understand all these terms, right? These are important, right? So as part of this video, I'm going to cover core network and architecture concepts, okay. So these 8 terms I will cover it as part of this video: architecture, IP addresses, domain name systems, HTTP and HTTPS, then REST APIs, proxies and reverse proxy, and API gateway, okay. And in the upcoming parts we are going to discuss about this data handling and communication terms like caching, okay, so very important. Queue message brokers, very important. Rate limiting, it's very important, this term. Then this throttling latency, it is also very important. And this load balancer, this is also very important, okay. Then we will discuss about this databases and storage in our upcoming videos. Database indexing, very important term. Database sharding, very important. Replication, very important. Then this blob storage, then this idempotency, then this eventual consistency, okay. Then we are going to discuss after that design patterns and principal terms, okay. So this gap theorem, very important, this gap theorem. Then consistent hashing, microservices, important. Scalability, very important, okay. So in almost all the system designs, your interview they will definitely ask you this question: how you will guys scale this application, okay. If there are a lot of users come, then what you will do, how you will scale your application, so very important term. Then redundancy, important term. Fault tolerance, important term. Heart rate mechanism, then this leader election, important term. This circuit breaker pattern, important term, okay. Then after that we move to this performance and delivery optimization terms like this content delivery network, very important term. Content delivery network, okay. Replication, very important, okay. System monitoring and metrics, health checks, then service discovery, then auto scaling, okay. So first let's understand these core network and architecture concepts, okay, these terms. So first is client server architecture, okay. What is this client service server architecture? So a design model where a client, usually a browser or application, okay, so it is going to send the request to a server, right, which processes and returns the response, okay. So there is going to be one client in, client is going to send one request to a server, and then server is going to respond to the client's request, okay. So response is coming back to client, okay. So example, you can say when you open YouTube on your browser, client, okay, which sends a request to YouTube's backend servers to fetch video data, okay. So this is nothing but your client server architecture, okay. So this is first term. Then second term is IP address, okay. So what is this IP address? It is a unique identifier assigned to every device connected to the internet, okay. So when you visit any website, okay, google.com, so it resolves to an IP address like something like that, okay, which your device uses to connect to Google servers, okay. And there are two types like IPv4 and IPv6, okay. So what are these two types? So let's understand these two types as well, okay. So see here. All right, so see here. So IP addresses, okay, internet protocol is a set of rules used to send and receive data over the internet. Every device connected to the internet is assigned a unique IP address, okay. So IPv4 means internet protocol version 4, okay. So format is nothing but this 32-bit address, right? 32-bit address. So something like this. Okay. So here each number is 8 bits and range is 0 to 255. Okay. So 0, how you represent 0? So you represent 0 like this, right? Here 8 zeros. Okay. In binary form if you write, and here 255 in binary form if you write, you are going to write like this. Okay. 8. Here you see 8 ones are there, right? Okay. So here see, here 192 in 8 bits we are representing. Okay, this 168 in 8 bits we are going to represent. This 0 we are going to represent in 8 bits. This 1 we are going to represent in 8 bits. Okay, so 8 plus 8 plus 8 plus 8 is nothing but 32. That is why 32-bit address. Okay, so here see, why is each bit 8 bits, each octet like 192, okay, is a number between 0 to 255. The binary range of 8 bits is like this. So 1 octet is equal to 8 bits, 1 byte. So full IPv4 is equal to 4 octets. Okay, there are 4, right, into 8 bits is equal to 32 bits total, right? So here we represent like this. Okay, this one. So it is written in dot decimal format. Okay, this internet protocol version for an example is this. Okay, now same way this IPv6. So this is nothing but internet protocol version 6. So this is the format. Okay, 128-bit address. Okay, each block is equal to 16 bits, 4 hex digits. Okay, it is written in hexadecimal and separated by colons. Okay, so here see colons are used, right? Okay, so here each block has 4 hexadecimal digits. Okay, so in total 4 hexadecimal digits are there, right? Each block, right? And so here 4 hexa digits into 4 bits, okay, is equal to 16 bits per block. Okay, so in each block we have 16 bits. So how many blocks are there in total? 1 2 3 4 5 6 7 8. Okay, so 16 into 8, if you do 8 6 are 48, 4 here, and 8 8 and 128. Okay, so 128-bit address, right? So here see, it is written in hexadecimal and separated by colons. One hexadecimal digit is equal to 4 bits. Okay, so here in one block you see there are total 4 hexa digits, right? So 4 into 4, 16 bits per block. Okay, one hexadecimal digit is 4 bits. So 4 hexadecimal digit is equal to 4 bits into 4 bits is equal to 16 bits per block, right? So here, for example, take one block. So here if you see this 2001, so 2 I'm going to represent like this. Okay, convert each hexadecimal to binary. 0 I'm going to write like this, 0 I'm going to write like this, 1 I'm going to write like this. Okay, so combined binary for 2001 is going to be like this, 16 bits, right? Okay, so 8 blocks into 16, 128 bits total, right? Here we have calculated this. So that's why each block is equal to 16 bits, right? So this is example. Okay, now here real life example. So IPv4, it is used by your home Wi-Fi, right? And IPv6, it is used by modern mobile networks or large data centers like google.com. All right, so this is about IPv4 and IPv6. All right, so now let's move further. So now here after this, let's discuss this domain name system. Okay, what is this domain name system? DNS. Domain name system translates domain names like facebook.com into IP addresses so browsers can load websites. Okay, so rare word example, like if you enter linkedin.com, so after that DNS lookup going to happen, then you get back IP address and then browser is going to connect. Okay, so let me show it with example. Okay, so see here let's suppose you are a client. Okay, so you go to Google and you search this. Okay, so this is your first step that you are doing. Okay, you are searching this. Okay, so now this is going to this domain name system. Okay, so from here IP address will come. Okay, one IP address will come. Okay, so domain name system transfers the domain names like facebook.com into the IP addresses so browsers can load websites. Okay, so after from this domain name system IP will come. Okay, and then this IP will go here, okay, to the server, right? This is step 3. IP is going to this server, and then from this server we are going to get the response. Okay, some HTML page, let's say. So this is for, okay, so this is complete process. So first client is entering some request, okay, that is going to DNS. From there we are getting IP address, and then we are using that IP address, and using that, with that IP address we are going to get the response from the server, right? So this is nothing but your domain name system. All right, now after that, fourth term is HTTPS. Okay, so this is nothing but protocols for transferring the data over the web. Okay, it's nothing but protocols for transferring the data over the web. And here HTTP, hypertext transfer protocol, this is insecure, right? And here HTTPS, so that simply means HTTP. Okay, and then other than this HTTP, there is also SSL TLS encryption secure. Okay, so here if you see, like any other website, in the top there is going to be one log symbol. Okay, if you click, so any website, okay, so here see right now, so here see this log symbol, connection is secure. So log symbol means that this website is going to use HTTPS only, right? So if any website is showing up something like not secure, that simply means that website is using this HTTP only, right? If it is showing not secure. Okay, so rare word example, when you log into a website, HTTPS ensures your credentials are encrypted during transfer. Okay, so here see HTTPS, hypertext transfer protocol secure. Okay, this secure is a secure version of HTTP. It uses TLS. TLS nothing but transport layer security to encrypt the data between the client and server, right? And what are the key components in HTTPS? SSL TLS certificate is stored on the server. It prevents hackers from reading the data. Okay, then authentication confirms the identity of the server, and data integrity ensures the data has not been modified. Okay, so these are the key components in HTTPS. And here if you want to see the difference, so here no encryption in case of HTTP, encryption via TLS. Okay, transport layer security in HTTPS, right? So this is URL. Okay, and this HTTP uses this port 80 and HTTPS uses this port 443. This is not safe. Okay, and this is not used in the payment methods. Okay, and this is mandatory to use in payments. Okay, and SEO impact is lower, and this is the preferred one by the Google. Okay, HTTPS. Then browser display not secure label. Okay, so if you see any website, okay, so if you see this lock icon, so definitely that website is starting from this URL. Okay, if you see this not secure, then definitely that website is going to start from this. Okay, so this is nothing but your HTTPS. Okay, now after that, fifth point is REST, that is nothing but representational state transfer. Okay, so an architectural style for building APIs that use HTTP method like get, post, put, delete. Okay, for to get any information, to post some information, okay, to pass some information, to get the information, okay, to update the information, and to delete the information. All right, so rare word example, you can say this get users 123, it is going to fetch the users with ID 123. Post, it is going to create a new order. Okay, so to get fetches the user. Okay, it is going to create a new, it is going to update. Okay, so here I can say get, I can say this is nothing but create, I can say this is nothing but update. Okay, this is nothing but delete. Okay, and here you can say r means read. Okay, so CRUD, basically like CRUD, right? Create, read, update, delete. Okay, these are nothing but the functionalities of this. Okay, representational state transfer, right? And here is used by Twitter API, GitHub APIs, Spotify APIs. Okay, all this stuff. And what are the key principles of REST? So one is stateless. Each request from client to server must contain all the information needed. Okay, right? Client server architecture, separation of front end client and back end client. Okay, so we have also made one project, right, related to employee management system. I will add that link in the description of this video. Okay, so in that we have separate backend and separate front end, right? And then how they are connected using these APIs only, right? We are using APIs in that, right? So that's nothing but separation of front end client and back end. Okay, right? So we can link them, right? Then the uniform interface, consistent way to access resources. Then resource based, everything is a resource. Okay, users, product, orders. Representation of resources are usually represented in JSON or XML. Okay, and here this is for read data, create data, update data, delete data. Okay, so this is the use of this HTTP method. Okay, next is APIs, application programming interface. Okay, so this is nothing but a set of rules that allow one software app to communicate with another. Like you can say Google Map API is used by Zomato to show restaurant locations. Okay, so Zomato doesn't have any their own map, right? So they uses Google Maps, right? So they are just using this Google Maps API to fetch the map details, right? So same way, if you are creating some weather application, so you can use some weather API, okay, which will help you fetch the weather information. Okay, so weather API can be used by a travel app to fetch weather forecasts, right? Okay, so if there is any airline, okay, or any trains, right? So they are just going to use these weather APIs, okay, in their application. They are not going to create one more system to get update, check the weather, right? They can simply use the weather APIs. Okay, they can use that. Okay, why they have to spend so much money again and again, right? So here, let's suppose you are building a weather app that shows real-time weather information based on the user's location. So you can use the API provided by this Open Weather Map API. Okay, so this is very commonly used. Okay, so you are just going to pass this information that https://api.openweathermap.org. Okay, and here you have to just pass like which location you want and the app ID, your app ID. So you will just go to this website, you will find out the details. Okay, how to use the APIs. Okay, so this like you can say there is one more application example that I can say in Zomato. Okay, so while payment, it asks you, right, how you want to pay. You want GPay, okay, or Amazon Pay, right, or Paytm, right? All these options. So these are nothing but using APIs only we are accessing, right? All these, right? Click on the method how you want to pay, GPay, Amazon Pay, Paytm Pay, okay, all these things. All right. So that's what. Okay, so then here see endpoint, you have to pass some endpoint, then query parameter like which city name, your unique API key to authenticate the request. Okay, so what happens internally, your app sends this request to the Open Weather Map server. The API server processes it, fetches weather data for London, okay, whatever city name you have to pass, and it is going to send back a JSON response, something like this. Like this is a city name, and what are the conditions? Clouds are there, overcast clouds, right, and temperature, pressure, humidity. Okay, something like this will come, and you can simply show all this stuff in your application. Okay, so let's suppose this is your front end. So there is one button here, you want to fetch the weather details. Okay, so you are going to call this API. Okay, so once you call this API, from this API you are going to get this response. Okay, and you can display this response here. Okay, current temperature, uh, weather, something like that. Okay, so you can just represent this. Okay, so now after this, what is this proxy and a reverse proxy? All right, so proxy servers, it sits between client and server to route or filter requests. Okay, so forward proxy and reverse proxy. Okay, two types of proxy. So forward proxy, it is used by clients to access the external resources anonymously, and reverse proxy is used by servers to distribute load and add security. So rare word example like NGINX, HA proxy used as reverse proxies in front of backend microservices. Okay, so let's discuss all this stuff in detail a little bit. Okay, so a proxy server act as an intermediary between a client and the internet. Okay, this is important line. When a client sends a request, it goes to the proxy first, which then forwards it to the destination server. Okay, so real-time example, you can say, think of a proxy as a receptionist at an office. You ask them for a document. Okay, they go and fetch it for you, keeping your identity hidden from the backend office. Okay, So proxy server act as an intermediary between a client and the internet. When a client sends a request, it goes to the proxy first, which then forwards it to the destination server. Okay, that's it. And what is this reverse proxy? A reverse proxy sits in front of the backend servers, example web servers, APIs, and forwards client requests to the appropriate internal services. Okay, so example like, now imagine a security guard in front of a building, right? Visitors talk to the guard. Okay, this is nothing but a reverse proxy. The guard then directs them to the right department. Okay, service, right? The building's internal departments are not directly exposed to visitors, right? So here they just visitor just talk to the guard. Okay, clients talk to the reverse proxy, right? The guard then directs them to the right department. Okay, that service. Okay, wherever they want to go. Okay, what is the right one? So the building's internal departments are not directly exposed to visitors. Okay, so here some key differences you can say. So proxy sits between client and internet, and the reverse proxy sits between the internet and backend services. Okay, and then the primary goal, hide client activity filtering, and here load balancing, security and caching. And it is used by clients, it is used by servers. Example, web filter in corporate networks and JNX in front of microservices. Okay, so we'll see all these terms in our upcoming videos, right? And real-time example, you can say a proxy server example. So company employees access the internet through a corporate proxy, right? The proxy filters harmful content, logs usage and hide internal IP addresses. Okay, and a reverse proxy example, a bank's website uses a reverse proxy, right? User hits the reverse proxy, which routes request to login, transfer or support microservices, helps balance load, add SSL and prevent direct attacks. Okay, so what are the key features of reverse proxy? So load balancing, so it distributes incoming traffic across multiple backend servers. Okay, load balancing, this term we will discuss in our upcoming videos. Okay, very important term. Then this SSL termination, it handles HTTPS encryption decryption to offload work from services. And caching stores static content like images, scripts to reduce backend load. Okay, so this is also very important term. We will discuss this in our videos. Security, it hides actual data, blocks malicious IPs, compresses response to speed up delivery, and authentication, centralized login or token checks. Okay, so popular proxy and reverse proxy tools. So these are the examples of them. All right. Okay, so now this is the last topic for this today's video, API gateway, right? So what is API gateway? A single entry point for managing requests to a set of microservices. Okay, these are the different functions: routing, authentication, rate limiting, very important term, logging. Okay, and a rare word example like Netflix uses an API gateway to manage millions of client requests per second, routing them to the correct microservice. Okay, now see this client. Okay, client request goes to API gateway. Okay, so these are nothing but the functionalities. Okay, routing, authentication, rate limiting, logging, monitoring, caching. Okay, so here you can say your Amazon website, right? So in that, if you want to see any product, so you will get you will go to that particular page. If you want to click on cart icon, you will go to that particular page. If you click on order icon, you will go to that particular order page. If you click on payment, then you will go to the payment page. Okay, so these are different microservices, right? Microservices, right? Different microservices. This is product page, this is cart page, this is order page, this is payment page. Okay, different APIs. Okay, so API gateway is going to take care of all this. Okay, all the routings, right? Okay, so here an API gateway is a server that acts as an entry point for all client requests to a system, especially in microservices architecture. Instead of calling services directly, client sends a request to the gateway, which then routes it to the appropriate service. Okay, all right. So real-time analogy, you can say, think of an API gateway like a restaurant waiter. You, client, okay, tell the waiter gateway what food data you want. Okay, now the waiter passes your request to the kitchen microservices. Okay, Now you don't interact with all other, right? So once the food is ready, the waiter is going to bring it back to you. Okay, so you never deal with directly with the kitchen, okay, individual services. Okay, right? So this is the real-time example, right? And what are the responsibilities of an API gateway? So request routing routes API calls to correct microservices, right? And authentication and authorization validates user using tokens like JWT or OAuth 2. Rate limiting prevents abuse by restricting how many requests a client can send. Caching stores frequently requested data temporarily to improve the performance. Load balancing distributes traffic across multiple instances of a server. Logging and monitoring tracks request metrics and errors. Transformation, it modifies request response format, headers or protocol as needed. Aggregation, okay, combine results from multiple services and send one response to the client. Okay, so proper API gateways are Kong, Amazon API, this NGINX and Zult Networks, very famous, right? And this APG, right? Google, right? So all these are popular API gateways that we use, right? So this is about the first part, that is nothing but your core networking architecture, right? So core network and architecture concepts. Okay, so in the upcoming videos we are going to discuss about this data handling and communication, like caching. Okay, why this is so useful, right? When we are accessing same data again and again from a website. Then message brokers, then rate limiting, very important. Okay, these star mark terms are very important. Okay, so in all the system design questions you can implement actually all these terms, somehow you can add them. Okay, you can add load balancer whenever you are going to design any application, right? So these are very important terms, right? How you are going to get the fast data from any website. Okay, right, all that stuff. Okay, so I hope that you guys are able to understand all these 8 points, okay, which we covered today. And if you guys still have any doubts, then please write in comment section. And if you feel that some terms are missing, then please also write them in comment section, right? So I hope that you guys are able to understand everything today. Please like this video and subscribe my YouTube channel so that you don't miss upcoming videos. Thank you. Bye bye. Meet you guys in the next video.